Hey guys, Lorenzo here. In this video I wanted to touch base on the basics of partition because it is one of the most fundamental things when it comes to Apache Spark. Here I have this very simple notebook. We are going to go through this and also through the Spark UI so that we can analyze the different tasks and jobs there. So, first of all, what are partitions? Partitions are the logical division of your data. When we are talking about distributed systems, you can imagine that big data frame being partitioned, different chunks of the data go into different nodes. And that is how we are able to process big data sets that are larger than the memory for a single machine. So here we are importing the PySpark library. Here I'm starting my session. One detail here is that I'm using 4 cores. I'm running this locally. Here we have the URL for the Spark UI, and we will take a look at that in a second. And when it comes to partitions, the default behavior is to set the number of partitions to be equal to the number of cores. So as expected, here we see 4 because we are saying that we are going to use 4 cores. The data sets for this example, I took that from Kaggle. You can download that. It is synthetic data related to airplanes and air travel. So taking a look at the data, we see that we have passenger ID, first name, last name, and then the information regarding where the flight started and where it landed, right? And then we have flight status. And for this example, we are going to do a very basic aggregation using the country of origin and then the flight status. So here we are reading the CSV, and as a first check, when we look at the number of partitions, that equals 4, which again is expected because that's the parameter that we have here. So we have this data, in this case, this is something very small. We can totally do this locally in your machine, but this will still suffice for the example. What I'm saying is that you shouldn't use Spark for something that is 10 megabytes. But the big picture here is that this data is going to be partitioned into 4 parts, and that is how we are going to process that in a distributed fashion. And then if we look at the number of rows, it's almost 100,000. And we'll get back to that number in a second. Let me open that. That's the Spark UI. So when it comes to the aggregation, first of all, we are adding a flag, whether the flight is canceled or not. And then this is simply calculating the percentage of flights canceled and aggregating that per country. And as we see here, the countries performing the worst are Andorra, Barbados, Anguilla, with over 50% of canceled flights. And let me just tell you again that this is synthetic data. This is not real data. We wouldn't expect 50% of the flights to be canceled. Otherwise, we would be looking at different types of transportation. And then if we want to look for the US, here it is with 33%. Okay, let's see. This is a good moment to see what's happening within the Spark UI. So the first thing that we can see is right here, calculating the cancellation percentage. That's the name of the job, and you can see that that is exactly what I'm setting here. And that facilitates, going to the Spark UI and seeing that specific job. So I use it quite a lot. So right here, if I open this in a new tab, and I click, let me maybe move that could get on the way, the little camera. But let's click on the stage. And a few checks here. So first of all, we see that we have 4 tasks, and that makes sense because the number of tasks will be the same as the number of partitions that we have. So we have 4 partitions, so here we see 4 tasks. And a few things to look. First of all, we see that one task is finishing much faster than the other ones. And here we have the number of records that they are processing. So clearly we see that task 3 has a much smaller number of records compared to the others, and that is an important thing that we need to look for, because the end goal is to have partitions that are taking the same amount of time. So we want all the cores to be, working uniformly. And one other thing, and this will explain how Spark is doing things. So again, we are reading the CSV file in partitions, right? And then what we are doing, if we go here, so we are doing a group by operation, and then we are doing a group by, and then we are aggregating, right? So what Spark is doing, it needs to, so we have the different partitions, right? But we need to make sure that we end up using all the data. So what Spark is doing here, it is doing a local aggregation. So it will run that calculation for the data that it has. And then it will write that to disk, those results. And then it is the driver that will do it is another executor, that will do the global aggregation. So if we look in here at the next stage, at the next job, we see that we are reading 700 records, and that is if we add this up, those are the records. So this job, or these tasks, they are doing the local aggregation. So we see 4 tasks for the 4 different cores, and then it is one executor that is pulling all of that and doing the global aggregation, which will be the end result, right? So that is what's happening under the hood. We need to understand that one task, there's a one-to-one relationship between the number of tasks and the number of partitions that we have. And we need to make sure that the tasks, they are taking the same amount of time. Otherwise, it would mean that the cores, we are not using the cores appropriately. So taking a look at that, then we can have a check to see, how uniform the partitions are, because ideally we want them to be the same size. So I have this helper function that calculates the rows per partition. And clearly we see that there's one partition that has a smaller number of records. If we were to repartition, and again here I'm setting that to 4, if we just call the function repartition without specifying a column, it will use a round robin partitioner, and it will make the partitions uniform. So here we see that. Now we see that all of the partitions have roughly the same number of records. So now we can run the same aggregation and see and compare the the tasks and see how much time is taking. So let's look at that. Let's go back to the Spark UI. And here we are going to see a few things in action. First, the repartition, so that's happening here. Let me move this. And here we see again the number of records that we have. And then again, we are going to do that shuffle right into disk. And if we take a look at this here, we now see that we are reading, those records that were shuffle repartition, and now the size is the same for all the partitions, so that's good. And this is a step where we are doing the local aggregation. So now we see that the execution time between the tasks is the same, and we are doing the same thing. We are computing the aggregation locally, sending that to disk, and it is the next step that will do the global aggregation right here. So again, we are reading those records, and we are calculating the global aggregation. So those are the basics of a partition. I wanted to show how the tasks relate to the partitions, and then we need to make sure that we go through the UI and we evaluate the performance. Thank you so much, and I'll be posting more videos on Spark.